Okay, so let's say that you're going to be an accident investigator. And so we've got a road intersection. We've got a car 1. We've got a car 2. Car 2 has a stop sign right here. Okay, but what happens is car 2 doesn't stop. They're busy texting or something, so they slam into car 1. The two vehicles lock together and slide off that way. Okay, and so as they slide off that way, let's say that this angle here is 46.1 degrees. Let's say that they slide a distance of 38 meters. Okay. Now, accident investigators want to find out how fast each car was going. Okay. Neither driver is able to tell them. Okay. First of all, driver 1 is unconscious. Driver 2 is busy texting, and they don't want to admit they even ran the stop sign. Okay. And the accident investigators trying to figure all this out. So what they do is they determine the mass of the car 1, 1370 kilograms. They determine the mass of car 2. So the mass of car 2 was 1950 kilograms. Okay. Then they slide the tires along the road surface to find the kinetic friction between the tires and the road is going to be 0.741. They measure the skid marks. Skid marks tell them it actually did slide 38.0 meters. All right. And so now they start working backwards. And they say, okay, we want to work backwards to figure out what happened. So it slid for 38 meters. So we can figure out that when it started sliding, conservation of energy, it's sliding along. So initial kinetic plus potential, okay, equals final kinetic plus potential. Oh wait, I said conservation of energy, but I also said friction. So there's non-conservative work in here. Now, the initial and final, we're assuming this is level, so otherwise it's more complicated. If it were not level, you'd have to include the difference in potential energy, but we're assuming it's level. Final kinetic energy is 0. So the initial kinetic energy is 1/2 the total mass, v squared, where that v is the velocity after the collision. Okay. Non-conservative work. What is non-conservative work? Okay, the non-conservative work is going to be friction times distance, okay, except negative because friction is opposite the motion. Okay, so what is the frictional force? Frictional force is mu sub k times the normal. Okay, so that's going to be mu sub k times the total mass times g times x. So this will be minus mu sub k total mass g times x. We can divide through both sides by the mass. We can work backwards, solve here. V, okay, is square root 2 mu sub k gx. So that would work through, that lets you figure out that the velocity was 23.5 meters per second. Okay, so it's moving here at 23.5 meters per second at an angle of 46.1 degrees. So the total momentum is going to be mv. So, that's going to be m1 plus m2 times v. So the total momentum is going to be 78,000 kilogram meter per second at an angle of 46.1 degrees. Okay. Well, that means we can find the x and y components. So that means that this is going to be P cosine theta I plus P sine theta j. And so that means that this is going to be 54,100 kilogram meter per second I plus 56,200 kilogram meter per second j. So how does that help us? Okay, so keep that in mind. We had object 1 like this. We had car 2 moving like that. Okay, so the initial momentum, P1, was just going to be M1V1I. The initial momentum, P2, is going to be M2V2J. Now, if they come together at right angles, the total momentum here is going to be P1 plus P2. So the total momentum is going to be M1V1I plus M2V2J. Oh, wait, we know those two components now. So that means that we can work backwards. That means we know that M1V1 is going to be 54,100 kilogram meter per second. We know that M2V2 is going to be 56,200 kilogram meter per second. But we know that M1 is 1370 kilograms. We know that M2 is 1950 kilograms. So that means we can find V1 and V2. So we just divide. Okay, so V1 comes out to be 39.5 meters per second, and V2 turns out to be 28.8 meters per second. Obviously way too fast to not have stopped at the stop sign. And so this is the sort of thing that an accident investigator would go through, working backwards at an accident scene to figure out what had happened. And so again, it's going back just using the physics and working backwards to figure out what was going on.